Good morning everyone. Today we are going to see one of the important topic in Java, that is abstraction. Generally I will give you one small example for abstraction, how we find it in daily life. Majority of us will go for learning driving, car driving to driving schools. There we are taught how you are going to drive a car, like to move the car forward or backward you need the accelerator to be pressed. To stop the car you need to press the brake, and to change the gears you need to press the clutch. There will be a gearbox, there will be a steering. If you want to turn the car to left you have to move the steering to the left, and if you want to move the car to the right you are going to turn the steering to the right. You are never taught that how actually the steering is working, how actually the car is stopping when you are applying the brakes. These all details are hidden from us. We are only taught that you want to stop the car, you press the brake. How the brake is working, that is never taught to us by any driving school. That is how they achieve abstraction, because they are hiding the irrelevant, or you can say they are hiding the irrelevant data or irrelevant information from us, because that is not needed to learn how to drive a car. If you need to have a mechanic training, then definitely you're going to learn those things. But for driving a car, to become a driver, it's not necessary that you know how actually all the parts of the car are working. In similar way, you're going to understand what is abstraction in Java. Generally abstraction means hiding details, and in Java we are going to hide the complexity by showing only the necessary details which are required. All the irrelevant and unnecessary details are hidden. So for example, to understand actually how abstraction is implemented in Java programming, we need to get to one scenario. Say for example, my friend wants to write a program which is going to find whether the sum of individual digits is a even or odd. Say for example, I have 234 as a number, and the sum of individual digits of the number is 2 plus 3 plus 4, that is 9. And now I need to find whether the 9 is even or odd. So now I hope you understand what is our scenario here. So here I need one class which is going to take input one number, and that number is individual digits of that number are calculated. The sum is calculated of those digits, and at the end we are going to find whether that number, whether the sum what you got is even or odd. So here I can break this situation into two parts. First thing is to find the sum of individual digits. So when you are finding the sum of individual digits, and after that you are going to evaluate whether the sum of individual digits is even or odd. So in my opinion, or in my situation, I don't want to show the user or the other programmers that how I calculated the sum of individual digits, because that is not necessary. What they are more what you call what they are more intended to find is whether the sum is even or odd. They want to see only whether the sum is even or odd. They don't want to see how you calculate the sum of digits and later on how you calculated whether the sum is even or odd. For that reason, I have written two classes here. Let me show you the first class, that is even odd, which is actually going to calculate whether the sum is even or odd. So here I have taken one even odd class, one main method I have used. I have used one command and argument by which I am going to pass one number, and I am stored in num variable, and this class cal, this is what actually I am going to perform abstraction by using this class. So this cal class I am creating an object ocal, and this ocal object, through this ocal object I am calling a calculate method, and this calculate method will be passed with the num value whatever we are going to give as a command line argument. So this num value is going to be passed as a parameter to the calculate method, and thus return of this calculate, the return whatever the value is returned from this calculate method is actually the sum of individual digits, and this sum of individual digits is later on divided modulo divided by 2, and if the remainder is 0, the or the sum of individual digits is even, and otherwise if the remainder is other than 0, then the sum of individual digits is definitely odd. So here what I am doing, I am just hiding the irrelevant information like how I am calculating the sum of individual digits, and I have written it in some other class and in some other method, and just I am using that method to return me the sum of individual digits. So here in my even odd class, I am not clumsy, I am not complicating my code by calculating the sum of individual digits here itself. For that I have used another class. So before that I will show you the execution. Say for example, here I am going to compile first, then I am going to show you the output with 234, or let me take another number here, say 521. Now definitely the sum of individual digits is 5 plus 2 plus 1, that is 8, and that is definitely an even number. And suppose I take one more number, say 523, and here say let me take 522. See, the individual digit sum is 9 and it is odd. So that is what the output we want and the output we are getting. So whenever any person sees your class, he will simply understand that okay, you are calculating the sum of individual digits by using some method, and later on you are finding whether the sum is even or odd by using a simple modular division. So this is how you are keeping your class simple, and you are hiding the irrelevant details. That is how you are calculating the sum of individual digits. Here I am going to show you how I calculated it. So this is the logic for finding sum of individual digits, and later on you are returning the sum, that is the sum of individual digits, back to your source class. So here the cal class is working as a layer here. You are hiding this calculation of sum of individual digits beneath your even odd class in the cal class, and on the top you are only going to see the even odd class, which is using the cal class to find the sum of individual digits, and that is how you are achieving abstraction here. So this is how actually the abstraction is going to work in Java. Can be seen in many ways. This is the small and best example I can give you so that you can understand it more better. Thank you for watching the video.